Hello, my name is Ekwe Jesse, and I'm going to be taking you on a professional course in power system analysis using ETAP software. I am an electrical engineer with a vast knowledge on the analysis of power systems using ETAP, substation designs, and power system protection. Now, before proceeding into the applications of ETAP, I think it is mandatory we know what ETAP is all about. Now, what is ETAP? ETAP is simply an acronym for Electrical Transient Analyzer Program. It is an analytical engineering software which enables electrical engineers to simulate and analyze the steady state and dynamic power system. ETAP is a software used by various sectors such as generation, transmission, distribution, industrial, transportation, and low voltage. Now, who is this professional course for, or who can attend this course? This course is for beginners who are new to ETAP software. Maybe you just got the software installed and you don't know how to go about it. This software is also for students preparing for their projects and thesis, or for graduated electrical engineers who intend to increase their skills and knowledge on ETAP software, which can be helpful in order to prepare and crack their interviews. Now, for undergraduate students, for your projects, you need this software because you'll be doing topics like voltage improvement, design of an overcurrent protection scheme, design of a distance protection scheme, and stuff like that. This course is also for professionals working for companies who need to perform the power system analysis and deliver the project. Now, this is a brief overview of what is expected in the course. Now, the primary purpose of this course is to learn power system modeling and analysis using ETAP software, which will cover a range of ETAP functionalities used to design and solve various power system practical problems. The course will begin with the software overview, proceeding to basics of creating a single line diagram, data entry such as parameters of transformers, bus bar ratings, transmission line ratings, and quickly expands the user's knowledge to include methods to automatically perform multiple what-if studies using multiple scenarios. Now, multiple what-if studies will be explained in a subsequent slide. Now, after performing the analysis, it is mandatory to know how to interpret the results generated by the software, so you will be learning that in this course. Now, this is a detailed outline of the course. The first thing we'll start with is the overview of ETAP software, where the interface will be explained. You'll be shown where you can find your AC component, your DC components, your protection equipment, the auto build, the continuity check, and everything that has to do with the interface of the software. After that, we'll be going into how to draw a single line diagram. After knowing where all components are, next thing is to learn how to connect these components and input adequate parameters. Now, after that, we'll go into load flow analysis. After drawing a single line diagram, the first analysis to be performed in order to validate the project model or the single line diagram you have drawn is load flow analysis. Now, primarily, load flow analysis is the study of a behavior of a power system. The study of the behavior of a power system is load flow analysis. Load flow analysis primarily involves four quantities, which are: the first one is used in the determination of various bus voltages. Secondly, their phase angles. Thirdly, active power flow, and the fourth one is reactive power flow. So we are looking at bus voltages, phase angles, active and reactive power flow. So after teaching how to run the load flow analysis, how to interpret the results obtained from the load flow analysis will also be taught. Then we look at voltage improvement, power loss reduction, and power factor correction. Remember, load flow analysis is the study of the behavior of a power system, which will reveal whether the bus voltages are within prescribed limits, whether a transformer is overloaded or not, whether a circuit breaker is overloaded or not. So we are basically identifying whether or not there is a fault in the power system, whether or not components are rated appropriately in the power system network. So after finding that, suppose we have inappropriate ratings, inappropriate voltage levels, and high margin of power loss. It is not enough to identify a problem, but it is better to identify the problem and provide an adequate solution to the problem. That is where voltage improvement, power loss reduction, and power factor correction comes in. We'll be teaching you how to improve a power system network. After that, we'll go into cable and transformer sizing coupled with creating various configurations. Now on the previous slide, I remember saying I will get into multiple what-if studies in the next slide. Now this is it. Configurations is creating different patterns in which the power system can operate. Suppose we have 2 generators feeding 2 transformers coming down to the load, maybe 4 feeders or thereabout. Now, various configurations is performing a load flow analysis, verifying if generator 1 alone can carry the load optimally, or generator 2 alone can carry the load optimally. Suppose generator 1 is down for maintenance or is experiencing a fault and is isolated, would there be optimal flow of power supply? That is what we mean by creating various configurations. What if studies? What if something happens to this? What if something happens to that? Would there be power supply? And not just power supply, would there be reliability and efficiency of power supply? That is what various configurations is all about. Then we'll go into cable and transformer sizing. After that, we'll enter short circuit analysis, where we have to determine the magnitude of fault current flowing through different bus bars, the maximum and minimum amount of fault current, in order to determine appropriate ratings for our protective devices. After that, we'll be moving into the design of an overcurrent protection scheme. Now, an overcurrent protection scheme is used to protect the system against overcurrent, as the name implies. Now, a short circuit fault is usually 3 to 10 times the nominal range of actual current that is supposed to flow through the system. So, the design of an overcurrent protection scheme mitigates the effect of overcurrent. Once there is an overcurrent, the overcurrent relay will sense it and then send a trip signal to the circuit breaker. And I'll be showing how to configure those relays in a way it will work efficiently. After that, we'll be moving into arc flash analysis. Now, arc flash is a spark of electrical current which leaves its intended path and travels through air from one conductor to another to ground when insulation or isolation between conductors is no longer sufficient to withstand the applied voltage. The arc can heat up a metal to a point of vaporization. It can also cause severe skin burns by direct heat exposure and by igniting clothing. Therefore, the analysis is necessary to determine the nature and frequency of occurrence of the arc in order to prefer suitable methods for protection purposes, thereby mitigating the consequences of an arc flash. After that, we'll be going into the design of a differential protection scheme. Now, a differential protection scheme is basically for transformers, where we'll be considering the effect of an internal or external fault, and we'll be configuring differential relays to protect the transformer against these faults. After that, we'll look at the design of a distance protection scheme. Finally, the distance protection scheme is a non-unit system of protection which measures the impedance between the relay location and the point where the fault is incident, and then it compares it with the already set values. If there are discrepancies between the values, the distance relay issues a trip signal to the circuit breaker. Distance protection scheme is usually used for transmission lines. After this, we can explore other modes of ETAP such as motor starting analysis, harmonics analysis, as well as transient stability analysis. Now, the benefits of this course. The first benefit is installation of the software for those that are yet to get it. After enrolling for this course, if you are yet to get the software, we can install it for you regardless of your location. By the end of this course, you'll be able to have a very good foundation on the fundamentals of power system design and analysis. You will also be granted access to real-time electrical networks with field data for study purposes. You will also have free consultations and assistance for students who are having difficulties with their projects. And finally, you have a lifetime access to videos and PDFs which we will share to you during the course of the lesson. Thank you very much. See you in the